Every matrix has special directions it only stretches, never rotates. Those are the eigenvectors. The eigenvalue is the stretch factor. This one idea underpins PCA, Google PageRank, RNN gradient stability, spectral clustering, and every technique that decomposes a matrix into its natural structure. The equation is A times V equals L times versus A is your matrix. V is the eigenvector. L is the eigenvalue, a scalar. Same vector on both sides, just scaled. Today we derive eigenvalues from scratch, compute eigenvectors by hand, and connect everything to 4 core AI applications. Most vectors, when multiplied by a matrix, get both rotated and scaled. Eigenvectors are the exception, they only get scaled. The direction is completely preserved. Consider equals 3, 1, 0, 2, and vector v equals 1, 0. A times 1, 0 equals 3, 0, which is exactly 3 times 1, 0. Same direction, scaled by 3. That is the eigenvector with eigenvalue 3. The second eigenvector is 1, 1, with eigenvalue 2, A times 1, 1, equals 2, 2, equals 2 times 1, 1. 4 cases. Eigenvalue greater than 1 means stretched. Between 0 and 1 means shrunk. Equal to 1 means preserved, this is PageRank. Less than 0 means flipped and scaled. To find eigenvalues, solve the characteristic equation. Det, A minus L times I, equals 0. For A equals 3, 1, 0, 2, form the matrix 3L, 1, 0, 2L, set its determinant to 0. The determinant is 3L, 2L, minus 0 equals L squared minus 5L plus 6 equals L3, L2. So L1 equals 3 and L2 equals 2. To find eigenvectors, substitute each eigenvalue back. For L equals 3, solve, A minus 3I, V equals 0. This gives 0, 1, 0, 1, times V equals 0, so V2 equals 0 and V1 is free. Eigenvector is 1, 0. For L equals 2, solve to get eigenvector 1, 1. In NumPy, NP, linear_lg.eig, A, returns both eigenvalues and eigenvectors in one call. 2 critical connections. First, trace equals sum of eigenvalues. Determinant equals product of eigenvalues. For our matrix, trace equals 3 plus 2 equals 5. Determinant equals 6 equals 3 times 2. If any eigenvalue is 0, the determinant is 0 and the matrix is singular, connecting video 11 to video 12. Second, eigendecomposition. For symmetric matrices, A equals Q times lam times Q transpose, where Q holds the eigenvectors as columns and lam is the diagonal eigenvalue matrix. This diagonalizes A, revealing its natural structure. For covariance matrices, always use NP, linear_lg, A, not EIG. It is faster and guarantees real results. 4 applications. 1. PCA. The eigenvectors of the covariance matrix are the principal components directions of maximum variance. Eigenvalues are the variance amounts. Project onto the top k eigenvectors to reduce dimensionality. Explained variance ratio is Li divided by the sum of all eigenvalues. 2. RNN stability. The spectral radius maximum absolute eigenvalue of the recurrent weight matrix controls gradient flow. Use orthogonal initialization to start with spectral radius near 1. 3. Eigendecomposing the covariance matrix decorrelates features and enables whitening. 4. For your monitoring network, The Fiedler vector, the second eigenvector of the graph Laplacian partitions devices into natural clusters for root cause analysis. 3 definitions to know cold. Eigenvector, the direction a matrix only scales. Eigenvalue, the scaling factor. Characteristic equation, det a minus L times I equals 0. Key facts. Trace equals sum of eigenvalues, determinant equals product, eigendecomposition A equals Q lam Q transpose for symmetric A. 2 exercises. Compute eigenvalues of 3, 1, 0, 2 by hand, then verify with NP lena lg.eig. Then for a covariance matrix with eigenvalues 3, 2, 1.5, 0.3, 0.2, state the trace, determinant, and fraction of variance in the top 2 components. You now have the complete picture of eigenvalues and eigenvectors, the equation, the geometric intuition, how to compute them by hand, and where they appear throughout AI. Video 13 is PCA in full, starting from raw data, computing the covariance matrix, eigendecomposing it, projecting onto principal components, and measuring reconstruction error. If you have ever wondered what PCA is actually doing mathematically, video 13 is the answer. Subscribe so it is ready. Drop your characteristic equation working in the comments. See you in video 13.